Good day everyone, I am Brendel Amsusas and I will present the Perlin design details which will be used on the STAAD program. So first is the occupancy category of the building, so that is 1, which is the essential facilities, and the location is South Pacific, Catalunan, Pequeño, Davao City, Philippines. For the basic wind speed of such location, that is 290 kilometer per hour based on NSCP 2015, and that is on figure 207E.5-1C. So for the exposure category, that is B, and the KZT, that is equal to 1.0 since there is no hill on the plan presented. And for the roof angle, since we noticed on the elevation that the roof is flat, so the angle is 0 degrees. So moving on, for the interior purlin, we have the truss spacing of 4.85 meters. So we consider the longest dimension based on the center-to-center spacing of the column. With that, the effective area. So first is we have the effective length 4.85 and the effective which is 1/3 of 4.85. So multiplying those dimensions, we have effective area of 4.85 times 1/3 times 4.85, which is equal to 7.84 meters squared. And for the overhang purlin, we have the length of 1.5 meters and the purlin spacing of 0.85 meters. So with that, the effective area is just 1.5 multiplied with 0.85. That is 1.275 meters squared. And for the roof mean height, based on the elevation plan, it is consist of 9 meters. Next is for the adjustment factor for building height and exposure. So that is the lambda. So the mean roof height of the building is 9 meters. So it is since it is B on the exposure category, so it gives the adjustment factor of 1.0. The next one is to determine the pressure on the um, purlin. So we have for the interior span of the purlin. So for zone 1, since our effective area is 7 point something, so we consider the higher effective area in order to be safe. So for zone 1, we have effective wind area of 9.5, and that will give us the windward pressure of 0.26 and the leeward pressure of negative 2.74. So for the zone 2, we have still the effective area of 9.5 to consider, and gives us the windward pressure of 0.96 kilopascal and negative 3.24 kilopascal for the leeward side. Now for the PNet 9. So the PNet 9 is actually the uh, pressure presented earlier. So this is just the summary of it. And for the PNet, that the formula is just the lambda times the KZT, which is both 1.0, and the PNet 9, which is these values here in the above table. So by calculating this PNet, this will give the following value here on the table. So for windward, for zone 1, that's 0.96. For zone 2, that's 0.96. And for leeward, for zone 1, negative 2.74. And for zone 2, negative 3.24. So we notice that there is no actually change on the value since the lambda and the KCT is 1.0. So next is the PNet 9 and the PNet for the overhang purlin. So the only pressure here is the leeward pressure, uh, which is negative 4.9 kilopascal. And also by calculating the PNet, which is the lambda 1.0 times KCT 1.0 times the PNet 9, this gives us the leeward pressure on zone 2, still 4.9 kilopascal. So for dead load, we have assumed that the roof material is metal deck 18 gauge, so that is 0.14 kilopascal. And for the live load, that is 1.0, uh, based on the minimum roof live load on NCP 2015. So the next one is to convert those pressure loads into line loads or uniformly distributed loads. So the formula of it is just the pressure load multiplied by the purlin spacing. So the purlin spacing is mentioned earlier, which is 0.85 meters. So that 0.85 meters will be multiplied on the pressure loads presented earlier. So for interior span, it gives us 0.816 for zone 1, and for zone 2, same value of 0.816 kilonewton per meter. For leeward, for zone 1, negative 2.329 kilonewton per meter, and for zone 2, that's negative 2.754 kilonewton meter. For overhang, we have for zone 2, the leeward, negative 4.165 kilonewton per meter. And for dead load, we have the uniformly distributed dead load of 0.119 kilonewton meter and live load of 0.85 kilonewton per meter. So the A here is the 0.9 meters.